Hey guys, welcome back. In this video, let's talk about Q, another wonderful data structure. Okay, in other linear data structures, we have one more interesting data structure called as Q. Q is almost similar like a queue in a real world scenario, guys. So, say for an example, that's a ticket counter here. Okay, and people would form a queue to buy tickets, right? All right, so this is exactly a queue. Okay, so we are going to implement a similar kind of thing, but you have two ends, right? One is called front end and another one will be called as rear end. And one important thing to note here is queue follows a principle called FIFO. That means first in, first out. One who makes to the ticket counter first will be the first, will be getting the tickets and will be the first to go out, right? So it is actually first in and first out. That's very important. Of course, I'll explain with this example. Don't worry, but this is very important, guys. This is first in, first out. Okay, please remember that. Okay, so let us take an example. So you have two important pointers called as front and rear. Okay, front will point to the front end of the queue and rear will point to the rear end of the queue. Okay, so these are the two important keywords, guys, as far as queue is concerned, right? And both the value will be -1 in case there is an empty queue. Okay, if there is no empty queue, then you have to increment the value. Okay, according to that. Okay, I'll teach you how to do that. Okay, so this is a queue. Say I have empty elements. So now my front is 0, my rear is front is -1 and rear is also -1 because there is no elements in it, right? So actually, if you see, this end is called as front end and this end is called as rear end. Okay, all right. So again, the basic operations are insertion and deletion, guys. Insertion is called as NQ. Okay, insertion is called as NQ, which is given by this, and deletion is called as DQ. Okay, so these are the two very basic operations that you have to understand in case of Q. Okay, insertion is called as NQ and deletion is called as DQ, guys. But you can't do that from both the sides. Okay, understand that from in the front end. Hold on, just a minute. In the front end, you can do only DQ process. I mean, you can delete elements from the front end, and from the rear end, you have to NQ. You have to insert elements from the rear end, and you have to delete elements from the front end. All right, and this should be done. Okay, please remember this. From front end, you have to remove elements. From rear end, you have to insert elements. Okay, you have to insert or NQ. NQ is a good word, right? Okay, let's see an example. Let's check. This is my queue. Okay, and I have front equals to -1, of course. Rear is also -1 since there is no element. Okay, I'll say NQ5. NQ5. Okay, will that be fine? Yeah, NQ5. Okay, what you have to do here is you just have to increment this rear. Okay, rear by 0 now because you are entering the first element, so rear by 0, and you are supposed to enter here, guys, 5. Okay, you have to traverse this and you have to enter at the first element. Okay, so 5. Of course, you are going to implement this using arrays only, so consider this as an array. So front is if front is -1, make it also 0 because you got an element here. Okay, for the first case itself, if front is -1, make it 0 because you got an element. Okay, that's why. So front points to the same element, rear points to the same element, right? And again, I'm NQing one more term, guys, maybe 10. Okay, what direction I should do? I should do only in this direction, right? So so if you see, 10 will come here and my rear will become 1, right? R will become 1. Front value will remain the same. Okay, only for DQing you can change the front value. But if you are NQing the first element, in that case you have to change -1 as 0. That's it. After that, the front value remains the constant. Okay, let's say I want to enq one more element, enq 105. Okay, so you have to, in this direction you have to put, right? So in this direction let's put 105, and you make rear to be 2, right? For first element the rear is 0, rear is 1, rear is 2. So rear also points to the, always points to the last element, guys. Okay, all right. Now let's say, okay, nq is enough. Let's go for a dq. All right, let's say I just wanna dq 5. Okay, dq should give like this. Okay, it's almost like a pop operator in stack. So give dq alone, it will remove the first element in the front, guys. First element in the front. So this will be removed. This will be removed. How do you remove that? This will be actually there. You just have to increment front. Front is pointing to 5, right? You just increment front. You just increment front by 1. So when front equals to 1 means it is pointing to 10 now. Okay, when front equals to 1, which means it is pointing to 10 now. Okay, you don't make it 0, since it's clear that now it has been deleted. Okay, if you dq it again, again front becomes 2 and it will be pointing to 105. Okay, so that's it. So what are the main aspects that you have to do for, if you want to enq something, increment the rear. Okay, increment the rear, and in the q just assign like this, increment enq the value that you have to enq. These are the two crucial statements whenever you have enq. Okay, and dq, when you want to dq something, just increment the front. That's it. Okay, because front is the front points to the first element. Okay, if you increment the front, then it points to the next element, and that becomes the first element. All right, so even if the previous element is still there, but we don't want that, right? Because we just want to track the elements using this front and rear. So increment the front, it will point to the, it means that it is pointing to the second element, so that becomes the first element, and the first element is already deleted. Okay, so almost one thing I wish to tell you here is, so let's say I have enqueued 5, 10, 15 and 20. Now our rear will have the value 3 and it will be pointing to here. Front will have the value 0, will be pointing to here. So I am dequeuing in this direction, right? Only in this direction I can dequeue, right? So first I'll dequeue 5, I'll dequeue 10, I'll dequeue 15. Okay, alright. So I'm enqueuing 5, 10, 15, 20 in the first, and then I'll dequeue 5, 10 and 50. Okay, now it is what is the value of front? Front becomes 3. Alright.